This is lesson 5, module 5, for finding the area of polygons through composition and decomposition. So a composite shape is a shape that's made up of two or more shapes. So if you look at this, it is made up of, I can see two rectangles. If I cut it here or if I cut it here, either way I'm going to have two rectangles. It's whatever way you would like to decompose it and cut it up into smaller pieces. So it says AB, we're going to go to the opening exercise. It's an aerial view of a woodlot. AB is 10 units. So I'm going to label AB 10 units. FE is 8 units. So from here to here is 8. A and F is 6 units. And D to E is 7 units. It wants me to find the length of the two other sides, D and C and BC. So I'm going to use what I have. If I look at this right here, and I'm trying to find BC right here, from here to here is 7. So from here to here is 7. And then I need to find this little piece. Well, the properties of a rectangle are opposite sides are equal. So if this is 6, then this is 6. So this is going to be 6. So BC is going to be 6 plus 7. So line BC is going to be 13 units. And we found that by adding. Now let's look at DC. So we're trying to find this. So from here to here, I'm going to look at my horizontals, is 8. And I used up, or sorry, not 8, 10. And I used up 8. So to make from here to here, 10 is this. I've used up 8. So what is this piece? It's 2. And I found it by doing 10 minus 8 equals 2. So I found that one by using subtraction. So this is 2 units. All right. The next one is this one right here. And it wants us to find, we can find the area of this. And we're going to find the area of it by decomposing this shape. We're going to break it up into different parts. So I'm going to cut it here. Where do I want to cut it? Let's cut it. Doesn't matter where we cut it, I can figure it out either way. I'm going to cut it so I have these two rectangles and the one on the bottom. So I'm going to find the area of it. So this one is, the base is 7, but what is the height? So I need this piece right there. This whole entire piece is 9, it's saying. But this is 4, so this is 4, so this is 4. So if I've used up 4, how much is this from here to here? Well, that's 9 minus 4, which is 5 meters. So to find the area of this purple rectangle, I'm going to do A equals BH. 5 times 7 is 35 meters squared. So now I need to find the area of these orange or red rectangles at the top. So base is 2, and the height 2 by 4. So A equals BH. The base is 2, the height is 4. That's going to be 8 meters squared. So these are all 8 meters squared, the ones on the top. So to find the area of the total shape, I'm going to do 35 plus 8 plus 8, or 35 plus 16, which is 51 meters squared. That's the area of the entire thing. And I found that by decomposing my shape and cutting it up into smaller rectangles to find the area of each of those and combined them with addition. Okay, next page. We already did this page. We already found the area of this, but it just wants us to show different ways that we could cut these up and decompose them. So we did this way already. We can also do this way. Or there's one more way that I could do, and it would be taking this shape and finding the area of that section right there, and subtracting it out. And I could find it I'll show you quickly of the area of this one by doing it this way. This is a 9 by 7. So this whole thing is 9 by 7. So it's 63 meters squared, because 9 times 7 is 63. Now I'm technically taking this piece out of it and subtracting it. And this is a 4 by, if this whole piece is 7, and I subtracted 2 from both sides, it's going to be a 4 by 3, because this whole line is 7 up here. If this is 7, this is 7. 2 plus 3 is 5, 6, 7. So this is 12. To find the area of it, I would take 12 away from 63, and it should give me, 51 meters squared. That's just another way to solve it. All right, let's go to S. Don't worry about all of these. I showed you, I just did them on the bottom to save time. So S20, we already did this. So think of this as a large rectangle with the piece removed. We already did that. So we did that I just showed you on that example. So make sure you may have to go back and pause it and write down this example, because this is the exact example. Sometimes it's repetitive. All right, so let's go to this one. So a parallelogram, ABC is part of a large solar power collector. The base is 6, the height is 4. Draw a diagonal line from A to C. Okay, so diagonal line from A to C. I probably should be using a math tool, but don't have one, so I'm going to draw a diagonal line from A to C. Find the area of both triangles, ABC and ACD. So they're both going to be equivalent. So this triangle here, I'm going to shade it in so you can see it a little better. The area of it is A equals base times height divided by 2. A lot of you on your math work, you're forgetting to divide by 2 for triangles. Common mistake, be very careful about it. So the base is 2, or not 2, the base is 6, the height is 4. 6 times 4 divided by 2. 24 divided by 2, which is 12. That one is 12, and this one is 12. And then what does it want us to do? Draw another diagonal line from B to D. Find the area of A, B, D. It would be the exact same thing, so don't worry about B. All right, that's just another way. And this is S20, so let's go to page S21. The trapezoid below is a scale drawing of a garden plot. Find the area of both triangles ABC and ACD. Then find the area of the trapezoid. Okay. What does it want us to do? Find the area. Does it want us to draw a triangle? Yep, we can. So I'm going to split it. Find the area of both triangles, A, B, C. So A, B, C, I'll shade it purple. I'm going to use A equals base times height divided by 2. The base is 8. The height is, I shaded it in, the height is 5 divided by 2, which is 40 divided by 2. It should be 20 meters squared. So ABC equals ABC. Now I need to find triangle ACD. So if you can't see that one, I'll shade it in. So, finding ACD. ACD. So the base is 4, and the height of it, so they share the same height, so it's still 5. So base times height divided by 2. 4 times 5 divided by 2, which is 20 divided by 2. See, it's mental math, but it takes me 2 seconds to write it down, which is 10 meters squared. ACD equals 10 meters squared. Find the area of both triangles, then find the area of the trapezoid. Okay, so to find the area of the trapezoid, which is this shape right here, I'm going to take 10 meters squared plus 20 meters squared. And I'm going to get 30 meters squared equals the area of the trapezoid. How else could we find this area? I could also, I'm going to show you another way. If I have a trapezoid, I can also split it like this and have 2 triangles in 1 rectangle. I could also find it that way. Either way works. All right, your independent work is going to be the problem set, lesson 5, 1 through 5 all.